Bonjour, good morning, everyone. So today I'm gonna talk about how to build a real-time data processing pipeline with Docker, Spark, Kafka, and Cassandra. And so I'm gonna give a little bit of my personal information. So I work at Docker. I joined 3 years ago when we were still at .cloud. .cloud was a platform as a service, and then we pivoted to Docker 3 years ago. And it's pretty interesting to see how the company grew from 20 people to more than 300 today. I joined on the finance team, and then I moved to the engineering team. Today I'm working with growth and analytics. So basically I'm taking care of the data processing pipeline that collects all the data from all the applications, all the business metrics that we monitor within the company. And we have lots of data coming from all the Docker APIs when someone sends like a Docker pull or Docker push. And actually, before I start, how many people are using Docker or have heard about Docker? Awesome, almost 100%. That's great. And how many people have built an image and pushed or pulled and tried something? Okay, yeah, that's great. So I think you guys will be aware about everything that I'm going to talk. That's great. So I'm going to give a summary about the talk that I'm going to give today. So I'm going to start with the background and the motivation about this project. So this project was something that I built during a hack day that we organized at Docker about 1 year ago, and after that, like, I'm going to give some details about what are the objectives with this project, specifically for this conference that's related to automation. So I think Docker helps us to automate and simplify the workflow, which is very in line with the topic of this conference as a whole. And then I'm gonna give like 5 steps that will go through like how you can do that. And at the end, I'm gonna give a demo, and you guys should see how easy it is to build something like this. So a little bit of background. What is the purpose of this project is, since we have lots of information coming from all these different APIs, different projects within Docker, the idea was to build something that we could collect information from different sources and have like a real data processing pipeline that we could analyze and see and visualize the data in real time. So the idea is to collect all this data and convert into meaningful information, and that's the main idea of this project. And then, like, one important part of this data that we are collecting is to understand the user behavior, to understand the features engagement with all these different projects that we are building at Docker, and also like to try to understand what are the parts of the projects that we should focus on based on the users' interests, and also like to have a standardized way of having the data stored and in a way that everyone within the company can have access to the data. So that was a little bit of the background. And for this talk specifically, I want to create this pipeline and process like lots of data in real time, and how Docker helped me to do that. So basically, I was able to automate the development environment with DrCompose. DrCompose, I think you guys have heard. You can describe how your application is structured. You can automate your machine management using Docker for AWS or Docker machine, so you can provision machines remotely, and basically this allows you to reduce the time to market and the time to develop. So if we have like a new hire and they want to start working on this pipeline and collect more data, you can basically give them like a Docker compose file, and then they can start working and having access to the data. You just plug to like a data source like Kafka, and you should be able to process the data and start using the project. So for this project specifically, this is how the language stack is organized. So we have a Python application that's talking to the Twitter streaming API, and it's sending data to Kafka, and Kafka is being connected directly to the Spark streaming to listen to all this data in real time, and in Spark we have a job that processing this data convert using the Google APIs. Like we get the IPs and we convert into geocoding, and we use Spark SQL to aggregate the data, and we send this data, this aggregated data, to Cassandra. And then there is a web UI, simple web UI, that you can see the data and visualize like on a map in real time. So that is one demo that I will show you, like very simply how you can build this and see how it works. So how can we do this? So the first step is to take all these different components and Dockerize them. So you have to define a simple script that describes your application. So in this example here, I'm just building like a simple web application using the engine, the Ubuntu image. I'm installing Nginx, and I'm building this image. So Docker build and then Docker run, and you have this Dockerized application. So you should do that for all the components of that whole application that we saw before. So that's the first step. The second step, you need to define your services and describe them in one simple way. And one way of doing this is using DrCompose. With DrCompose, you can create a simple file that describes each one of your services. For example, here we have a containers service, and we have the web service and the red service, and you can connect them together by using links or by using a swarm. So by having this file that describes your whole application, you can spin up your development environment with one command. I'm going to show you how it works at the end. So basically, once you have all these applications described in a compose file, you can spin up this on your laptop locally, and you can see this whole these applications being talking to each other in your laptop, and basically you can do a Docker compose up, and that's what we are going to see when I do the demo. So I'm going to spin up like the Zookeeper service, the Spark Master, the Kafka, the Twitter Kafka producer, the Cassandra, the Spark job that process the data, the web server that visualize the data by talking to the APIs, and the Spark worker. So this you can build in your laptop, and if it's working as you are expecting, you can move to like a production or at least a development environment on DigitalOcean or any cloud provider. And in order to do that, you can. I was using Docker machine, so you can easily provision a machine either like a virtual box on your laptop, or you can provision DigitalOcean instance or AWS or any other cloud provider. So that's like simple tools that you can use to automate. Like you can use these tools to automate your whole workflow, to provision machines, to spin up the services, and this helps you a lot in terms of development, in terms of having other developers using your application and learning how to build. Like at Docker, we have lots of people, they join and they, oh, how can I start coding? How can I start doing stuff? And we have there like the same image that goes from staging, production, and testing. So the developers have like one Docker file, or one DrCompose file that has like lots of services, and they can have like different extensions, and you can use like a kind of like inheritance and the same way that you program basically. So once you have this working in your laptop, you can basically use like any orchestrator. In this case, I'm using Swarm. You can scale up, scale down, and you should be able to run this application in production. You have to have like lots of other like monitoring things and alerts, like in order to move it to production. But you can scale up, scale down, and update your service very easily with some orchestrator. In this case, I was using Swarm. So I'm gonna give you a quick demo on how I built that and how we can easily show this application. So is it big enough? No. Okay. So here I have my directory, and yeah, I cannot see it here. I only can see it there. So so we have here this directory, and I like each one of those directories are like each application. So I have a Docker file for each one of them. I was developing this for this hackathon, and it was private, but today I'm gonna make it open source so you guys can see the code and play with it. So I'm gonna actually make it public right after we finish this presentation. So let's see what we can do. So here we have a DrCompose file. If we do this guy, so I don't know why we're not. 1 second, it's very hard to see. So I'm gonna. Okay. All right, so now it should be better. Okay, so here we can see that actually we cannot see very well still. I'm losing the pointer here. All right, anyways. So you guys can see that there is a Zookeeper service, a Kafka service, Spark Master service. And if we go down, we have a Cassandra service, we have a Spark Worker service, and we have a Kafka Twitter producer service, and a web service, and a Spark job. So basically, we described like all these services, and we have the environment variables that we need for each one of them. We describe the links where we say which service should be seen by each other in order to communicate. You can do either like links, or you can use Swarm to link them. This is using the links, but links is being deprecated, when we can use Swarm to or services to talk to them. So with this file, we have all these configurations. I put my on the GitHub project. There is nothing there, but if we SSH to my master node on DigitalOcean, we have the same compose file. But now I have added this Kafka advertise host name, which is the IP of this machine. And down here, I added my access token, the secrets, some API credentials to talk to the Twitter API. And that's pretty much it. You can also add here at the end the Google geocoding API key if you want to send lots of requests to convert the IP to geocode. But since we are just gonna use a couple of API, or not thousands of APIs, we can ignore this and use the service without any credentials. So with this defined, we can do Docker compose up. So first I'm gonna show this compose file with everything running in my simple node. All these services are running in different containers. So if we see here, we have all the services running. They have the configurations. They are talking to each other. And if we see this, the service, which is the web service, it's exposed on the port 80. So if I go to the browser right now, so actually, let me see if we are. So we need to specify the tokens that we want to listen to the. Okay, so I have two keywords here, Docker and Google. So actually, let's start only I'm gonna show you, I'm gonna listen only to the Docker one. If I do, I changed the token to Docker and Google to only Docker, and I just restarted, and it's restarting only that container that was changed. So if we go to the browser right now, oh my god, where is it? All right. So here is all the tweets that are mentioning Docker right now. Like if you tweet something, you should see your tweet there, and we can see the location here. Like let's see, we are right here. If you guys tweet something, we are gonna see something in real time. Can you guys test it? Like anything, test Docker. Like we are listening to the Docker keyword. All right, here we go. So, and this tweet is right here. So this is listening to the Docker keyword. If we go back here, where is the pointer? All right. So if we minimize this and we change the that keyword to now start to like so let's use the TIAD keyword. So now if we do DrCompose up, it will restart all the services that were changed. And in this case, it will restart only the Twitter Kafka producer. And you see that we are going to start seeing all the keywords related to the conference today. So everything is decoupled. You can change the backend and the front end. So let's imagine that now we have like all this like this web service is only one container right now. Let's imagine that you have like lots of people going to the website and it's very slow. So in this case, I have another Docker file here. I'm gonna stop this. Like if I do DrCompose stop, it will stop all these services. And I can also do this. So now I deleted all the containers that were running here, and I have another compose file that only has the backend services, and we don't have the front end service. So I'm going to start all those backend services. So here we created all the services, but not the front end. So if we try to hit this page here, there is nothing running there. So I'm going to create a service in a Swarm cluster. So if we look at the nodes here, I had created a swarm cluster before. We have two nodes. There is one master and one node. And in order to do that, it's very simple. It's just two commands. So let's now create a service. So let's give it a name, web server, and there is one environment variable that we need to pass. So yeah, I was trying to find if I had the. Oh, sorry. You guys know better than me. Service create -- name web service server, and there is one environment variable that we need to pass that I was trying to find. Let's see. It's very hard here without seeing. Okay, so yeah. So if I look at the Spark, here, so it's this one. Docker service create -- name web server -e, and this is the IP of this machine. Where is the pointer? One second. Okay. Yeah, I'm really sorry guys about this. So now I got the IP. So that's the IP, and I think that's pretty much it. And expose the port 80 for the service 5000. Now I give the image name and then the start.sh as the start command. Yeah, that should be it. So if I do this, I will create a service that has that environment variable, and I'm going to expose the port the service that is binding on the port 5000 to the port 80, and that's a service. So the good thing about it is that this can be load balanced. So now I can spin up, scale up and scale down the service, and I should be able to handle the load if there is like a big load. So if I do service ls, there is only one replica running, so we should be able to see that service here. Yeah, so it is back. So like imagine that now we have like lots of load on this web service. It's just a Python app that's running like with one process. It's not like a multi-process service. So we can easily do Docker service scale, and then I give the web server, which is the name of the service, and equals to 3. So now if we do Docker service ls, we have 3 replicas running. So like every time that I'm going to hit this page now, it will it will be like it will be serviced by 3 different backends. So it's load balanced like a route robbing strategy, but you can change it to be like a different strategy. But it's basically like doing the route robbing load balancing. And so it was like very simple to build like this Docker file from your machine, and now I created the service, and it's talking to the backend, and I can scale up, scale down. You don't need to worry about like the 5000 port that is being bind for each one of the containers. Like we have, like if we look at the services here, so Docker service PS web server. Oops, web server. So we have like 3 containers running. 2 of them are running on the master node, and 1 of them is running on the nodes, on the worker node. And this one was the first one that was running 2 minutes ago, and these were the 2 new ones that were spawned up when we scaled to 3 nodes, since we have only 2 nodes here. But we can easily join another node, and it's just one command. So it's very simple to take one application and being able to scale up, scale down your service. And that's pretty much it. If you guys have any questions. So on this project, I used Docker, Spark, Kafka, Zookeeper, Cassandra, and D3 for that for the UI. So let me open source this right now. So I have like a simple README file here that describes what is under the hood, what we are doing, and like the steps to like provision a machine can be either like on DigitalOcean, Azure, VirtualBox, or any cloud provider that you want. Then you need to update the Twitter credentials. You need to clone this repo somewhere, update, like create a Twitter account to get the credentials, and set the keywords list that you want to listen to, and then do a compose up, and it will work. So it's very simple. You can play with it, and let me do this. Here we go. Now you guys can see the source code, and if you have any issues or pull requests, you are welcome. And that concludes my talk. If you have any questions, let me know. I'm sorry about all this trouble here. It was hard to find the pointer. Thank you very much, everyone, and feel free to ask me any questions related to anything that you saw. Or, yep. This. The service?
The service.
Oh, the Docker service?
The web server service.
I see. Yes, you have like a different format we call DAB. So a DAB file is a different format. So basically, you can, like with this, where is it? Here. So basically, you can just create with the Docker. You can do a Docker Compose bundle. Docker Compose button will generate a file which is a .dab file, and that file has all the services in it. So let me show you. So if I do Docker Compose bundle, and then I specify the Docker Compose file. So now, if you look at this file here, where is it? So this DAB file it contains, if you do cat data. So all these informations here are services. So you don't need to type like on the command line. All this, like it's a JSON-like file that describes what you do on the command line.
Okay, so I cannot do it directly with Compose. After I deploy on the services, I must do bundle to produce a JSON in order to. So after that, with JSON, I can redeploy the whole thing with services.
Yep.
Okay.
Correct.
Thank you. Okay. It's okay. Thank you.
To change what? Sorry.
The balancing bot between different services.
Oh,
between
yes.
different Docker services.
So when you create, so if you do Docker service, create -- help. We have here. Oh my God, the pointer is very annoying. So the mode is replicated. I don't recall where we changed the, but I can do a quick search and I come back to you. But there is a way to change the logic.
As I know, it's only root robin, and actually we are searching a way to change it.
Oh, okay.
And as I know, it's only root robin with a VIP or DNS, but only root robin.
Mm-hmm.
That's why.
Yeah, I will do like a quick search and I come back to you.
Okay, thanks.
Any other questions? Well, thank you very much.